Okay, good afternoon. Today we'll be having basic introductions to neural networks. So today only it's basically we'll try to understand the basic building blocks of a neural networks, and this building blocks neural network then we will use tomorrow to build a simple neural network based classification models using all these basic concepts. So that's the basic classes which we will be discussing today. Okay. So today, as we are aware that there are two basic techniques of machine learning classification. So machine learning and as well as CNN-based classification scheme, which you might have come across. So last week we discussed about the machine learning classification scheme. So under the machine learning classification scheme, the objective is to first define the feature itself and then use those features to carry out the classifications scheme. So for example, in the last class, in the random forest, which we are seeing that the feature which were being represented were the band values of different images. So that's what we were taking. We were taking band values 1, 2, 3, 4, 5, 6, 7. So total 7 bands which we used. And those band values for individual pixels was representing a feature. And using the classification scheme on the top of that, that is the card algorithms, and creating multiple ensemble card-based trees or algorithms which we can create the random forest, and that resulted in the classification scheme. In case of neural network based, or mostly the convolution neural network based, the task of extracting the features along with the classification, both tasks are being carried out in the same computational architectures. For example, in the case of buildings, like we are having an example over here, where we are having a different type of built up which has been presented in individual image chip. So we are having a buildings where individual buildings are there, and there are also multiple buildings representing the different buildings. So like multiple instances of those buildings are also there in an image. Similarly, if there are very less amount of houses which is present, so those are basically in a sparse residential area, then we are having a full coverage of trees within the forest area. So that is being represented in this case. Similarly, in specific features like tennis court and so on. So if you start looking into all of these, there are specific component of different features which we are seeing. For example, in case of single building, we expect that it will have a kind of linear geometry. So linear geometry means you can consider that there will be a few lines and regular shaped polygons, maybe rectangle or pentagon, hexagon polygons, and those polygons will have a very distinct edges within the edge, within the boundary of a building. You'll be having an homogeneous representation of the pixels. Or in case of multiple buildings, which we may observe that there is a regular patterns based on small geometrical objects getting repetitively arranged in any one of the directions. or in case of sparse residence, we may be having multiple edges depicting the boundary of buildings, and along with there will be a two zones within the image which can be which can segregate. One is inside the building area, and another one is the area which is outside the building boundaries areas. So in such cases, outside the building boundary areas will have one type of homogeneity in your images, and within the building area also will be having a one type of homogeneity. Similarly, in case of forest or a tree area, will be having a lot of regular shape, especially in terms of canopy tree. So if you're having a tree with a fixed canopy sizes, so circular canopy or any regular circular canopy we can identify with the help of edges. Along with that, there will also be a few texture parameter, because in the canopy there will be a few shadow regions, so it means like there will be a few in your image will be having a lot of texture informations and so on. So if you see all these, there are if you see the commonality between all these features are that there are basic geometry which is a particular shape, and along with the content which is present within the boundaries or outside the boundary features. It means like there will be two different distinct characteristics. So if you think of in a particular zone, and if you think of a set of images, then you might observe that all the buildings looks like a kind of having a similar kind of color or texture patterns, and they may be having a fixed set of geometrical representations, maybe a set of union of multiple rectangle or a cube or maybe a pentagon combined together, that may be there. So if you see that, so those are the individual components like edges and corresponding homogeneity is present in each of those images. Now, whenever we create any kind of convolutional neural network, so what happens is the basic objective of this convolutional neural network is that the extraction of individual edges, their homogeneity parameter, their heterogeneity parameter, everything has to be extracted at first, and then at later stage those extracted features will get combined, and so that the particular the categorization of the features can be carried out. So identifying the individual component of building, its homogeneity and other details are actually a part of CNN neural networks, and that's how the CNN neural networks are able to differentiate the different classes, and it is able to provide the output. So in this case, you are not creating the features, but you are only providing these samples. Where in case of machine learning, you do a two steps supervised classification. One is the input data set which you provide, and along with that, you also tell that from these input data set what should be considered as a representation of an object which needs to be classified. Where in case of CNN, only you provide a set of samples, and based on the samples, it identifies different features, and classification of those features are also be extended. So this is the basic differences between CNN and CNN models. So now we'll see that the basic components of building a CNN models. So the CNN model actually, you can think of the genesis of all these CNN models are actually a basic perceptron. So perceptron is actually an you can think of a neuron-inspired computing model. So under the neuron-inspired computing model, what happens is that there will be a lot of input link through which the informations will be ready. Then in the case of neural inspired computation, it is assumed that all the different input which goes to a particular neuron takes a kind of multiple summation or multiple understanding, multiple data input, and based on the combined information provided, it gives its own verdict that shall it transfer the informations to the next neuron or not. So that's how the computational neural network, that's how the traditional neural network works. So in the case of computational neural network also a similar thing happens. So you'll be having the input data set with a predefined weights, and then what you will do is you will combine them together in a form so that you'll get an output, and that output will be always compared with a threshold. So if a value of output which is nothing but combined signal informations weighted sum of all those signals, if it is greater than on a specific trigger values, then the particular neuron is going to forward that information, otherwise the information will not be forwarded. So this is the basic linear perception models which is inspired from basically the neural network. How does the neural network works on the basis of that? So in the neural network, the input is actually an S cells and the output is actually an R cells, and in between you are having a multiple interconnection between them, and then providing you the output. Same is also is the case over in linear perceptor models. So slowly what happened is this linear perceptor model got further extension with the computational increase in computational power, and people started using it multiple layer of it. So instead of having a single perceptron layer, single perceptron which is taking all the inputs from the different input layers. So in this case, all the blue line is actually basically in this case the input blue line, the input layer is actually a blue line which represents the input to neural network, and the purple color output is the output which gets generated, and in between you are having a lot of intermediate layers which is nothing but a stacked perceptron. So different perceptron having full connectivity to all the previous layers, and the corresponding output gets created for generating the output. So in this case, so this is when people started using multiple stack of it, then we call it as a neural networks. So in this case, if you see that the basic architecture of neural network is almost same as a perceptron, that you are taking the input and connecting it to all the possible outputs and then generating the output. So that's the basic structure is same, but only difference is that between the input and output layer, now you will be having a multiple hidden layer. So when you add this hidden layer, then what happens is that you can look for a kind of multiple separation of different classes based on nonlinear discrimination or nonlinear discrimination functions. So what it means is, let's say you are having a few class or few data points, and which is not linearly segregatable. So it means like you're having a data points where two data points are intermixed, or there is some other geometrical patterns is present in your data set. Due to that, you cannot differentiate between the multiple classes with a linear connections. So in those cases, if you use an multi-layer neural network, then you will be able to differentiate or create discrimination functions which can help you identify two separate group of classes which will be non-linear, and that's the actually usefulness of the earlier neural network with multiple hidden layers is observed, and that is being used in different classification schemes. In fact, such neural networks can show that you can get or compute the principal components of input data set. So let's say if you're having a five input data layer, and if you want to compute the three principal component out of it, so you can compute them. So it means like you'll be having a minimization error, and based on that computation will be computation can be done to generate the output. So general basic model of all the neural network is represented in this slide. So the slides basically talks about the input layer, which is being shown in a pink color, and corresponding a single output layer. So this output layer will give you the output in terms of what the total understanding of the input data set is there, so that will get created and generated. So in this case, each of the input layer are actually represented as a linear vector. So now in case of satellite based image processing techniques, all these different input layers may be multiple band input values. Like for each of the pixel, you can have pixel locations, single pixel location, you may be having a multiple data. So that can be one of the representations. Or you may also have a two-dimensional representation of a piece of images. So you may be having an image of 5 by 5 or 7 by 7 or 28 by 28 pixel, and within those 28 by 28 pixels will have some kind of interrelationship, so that it can provide a distinct features that can be used by the neural networks to do a classifications. So you may be having that structure built in for each images. So in this case, as the input layer is given as an X, and then you will be having two other supplementary computations steps which needs to be carried out. So like in this case, first layer, first hidden layer, which is Z1, basically takes the input from all the inner input layers. So it's taking the input value from A1, A2, A3, A4, so that is nothing but the X1, X2, X3 and X4. So input data itself is directly getting fed into the individual nodes. Now with these individual nodes, we take or we randomly select at the beginning a few weightage, that how much weightage should be provided to individual nodes, and based on those weights, the first output of input response is getting generated, and that is being provided as an output to which gets processed by an activation function at layer 1. So like over here you see that The activation function is basically decides or tells that does this particular sets of input data set generates a meaningful information or not. So it means like this is only a two state which will be decided by the activation function. So there may be a multiple activation function, tan h, relu, and sigmoid functions and so on. So this basically tells that if any one of the sample values is greater than 0, then the corresponding output of all the weighted sum of individual input layer is going to give the output each of the input layer or Z input layer takes the weighted sum of all the input values, and corresponding a bias is getting added, and based on the output or the weighted sum of individual inputs, we do a comparison with the threshold. If it is crosses the threshold, the output of these individual computation is being forwarded to a next layer. So like in this case, this formula basically represents the different weight which is provided or which is available. So like in this case, Wm is a weight which is representing the weight transfer of weight for the first layer and the second first hidden layer, first node, and first hidden layer second node. So first row of this W matrix represents the input weight for input weight to the first hidden node, and set to the second hidden node of first layer is being represented in the second row. So if you see, this total networks in this case can be represented with the help of a set of such combinations. So all this is being shown over here, that X is an input layer. Then what we do, we take an weighted sum of input layer for each of the nodes, and then finally we carry out the activation functions. When that activation functions generate some output, so that acts as an input to the next layer, and that next layer summation is being carried out with the same manner as it would have been for the first input hidden layer, and that goes on. So after the first and second, the third layer output is simply a summation of third weight matrix, which is going to multiply the input value from layer 3 activation functions A1 and A2. So all these are being put together is called a feed forward process, and with the feed forward process, what happens is your input data is getting converted into some other numerical encoded values, and that gets generated by output signal S. So this whole process is the forward network computations. So later on, what happens is that when this forward layer or when the feed forward operation works out, then it generates a few weight or few values based on the given input. Then what we do is, during the training stage, what we do is we take the output generated by neural networks and we compare it with respect to the corresponding ground truth value which is present. So for doing that, what we do, we simply compute the differences between them as the output differences between the actual predicted output and the actual output, and we can create an error, and that error can be used for providing the input to your whole networks, so that it can act or it can provide a kind of readjustment of those weights. So in the back propagation algorithm is actually a way to readjust the weight. So in this case, what happens is that based on the error value which is being computed, we readjust the individual weights for each of the nodes. Like in this case, the layer to hidden layers or the layer 2 weight is getting computed or is getting corrected based on the total error which has been generated. So due to that, what happens is that there are multiple components involved in it. So error is actually dependent upon the activation functions. Activation function is again dependent upon some kind of input influence of input influence which may be present. So taking all these activation function input and as well as the impact of input values, all these three are combined and is being represented as an using a chain rule. That's a product chain rules to provide a kind of required chain which needs to be carried out in the weight to reduce the overall deviation generated by the models. Once we compute this deviation values for each of the weight, then what we do is we simply do a correction. So that correction is basically done on the basis of a few parameters. So earlier values, W2 is in this case is actually representing the earlier values, and based on the learning parameters gamma, the corresponding computed deviations, overall deviations which is based on only on the input 2, in this case that particular function is or that particular input is being taken to do a next level iteration. So what happens is in the back propagation based training model, this particular loop, the computation of the error, then recomputation of the error, or basically to carry out the derivative based back propagation network, what we do is we generate this generates the output values, and that's where we do a complete correction. So this new weighted values of W2 will be used in the next time and in the iteration, and this whole loop continues till we get a error which is minimum from in all the iterations. So this process is actually called an minimization error, which is basically, again, as you increase the iteration, it is expected to the overall error should reduce to global minima, and due to which we may get an optimum weight that can be used to represent a neural network. So with this basic background of backpropagation and neural networks, now we'll be moving to the uses of all such neural network in different contexts. So those are basically based on and based on that those uses, you may be having a different type of networks. So one of such networks is actually a encoder. So encoder, what it does is it basically takes the input from all the input layer, and it also generates the output or which is having an output nodes similar to the number of input layers. So it means like input and output where look like identical, only differences will be that the input layer will be connected on the first, and the output layer will be connected at the building the whole network. In between an input output, you may be having a varied number of attribute data sets, attribute nodes, and these attributed nodes are actually hidden nodes, and these hidden nodes basically combines the information from multiple input feature values to get a final output. So as you can see that in this case, if your input is being provided with a separate input, so and with this 8 by 3 by 8 neural networks, when you do an encoding, so all the input layers which was separate or segregated are now decoded with the help of the weighted values of the individual nodes or individual nodes of hidden layer. So that's how we can decode, or we can encode the input values to the output values, and that can be used for different purposes. So that's how the and this whole architecture or is called basically an auto encoding. Then sometime what may happen is the having an input layer suddenly going to only a few set of input layer and again expanding may result in some kind of biasness in your computation, or there may be a features which may be dominant, but during the prediction phases we may not have all the encoded values. In that case, what happens is that we can create a multiple stack of encoders. In this case, output layer and input layer will be identical in terms of number of nodes, but with the help of different neural networks, we can create multiple stack of the features. So this basically allows to extract the features at different scale. So if you in the previous case, especially in the autoencoder cases, generally the dimension of the input data set goes drastically. So that may be useful for general cases, but which may not be good for for specific applications. So this is basically a multiple stack encoder that is being provided over here. Then we are having a CNN architecture. So under the CNN architecture, what we do is we take a fixed size of input images, like in this case 32 by 32 is the small stack images, and what we do is then we carry out a kind of classification of these image to label it. For example, this whole images can be labeled as a forest, or maybe it can be labeled as an urban areas and so on. So you can label them in a different ways. So for that, what we do is in the CNN architecture, I was telling that it helps you to identify the features, to create or to let the network work and get the different or get sufficient features, so that during the classification stage it should be easily able to decode the images and provides an appropriate output. So to do that, there are two major distinctions which needs to be thought of. One is the like in this case, all those full connection and above. So in all these, this is basically a RelNet 5 architecture. So all the full net connection at the right hand side will look like a kind of traditional neural network. So whatever the traditional neural network which we saw, which may be having a lot of multiple input output multiple output nodes, and each of those output nodes are fully connected. So it will look like that after carrying out a set of convolution and sampling process, whatever feature we get in, those features are basically being used for carrying out the classifications. So in case of CNN architecture, this is the basic shape. So the advantage of CNN architecture in corresponding to NN architecture is that in the CNN, the spatial context or spatial information or the objects foreground and background relationship, we can also extract it from the based on the training data set, and that can be used for carrying out the better classification scheme. Where in case of normal neural networks based system, the advantages of the advantages of spatial context is not available, and the normal neural networks basically loses those advantageous information. So people have also tried to use these traditional programming languages like Python based systems where they takes care of these architectures. So CNN has one of the important component called convolution. So convolution, what it means is that you create a set of a smaller subset of filters in compared to the input images, and these filters are supposed to have some kind of inbuilt feature built in. So it means like it is expecting that whatever you want to carry out with the input data sets, you can create a subset of each of those images, and from this subset you can extract useful information. So each of these subset useful informations can be considered as one of the input features. So input features is nothing but a small subset of an whole images, and that small subset of whole image actually represents the some specific features. So it may be edge identified filters, or it may be texture identified filters, or so on. So in this case, we are not giving the weight to these filters, but rather than the algorithm itself adapts it using the back propagation algorithm, so that the filter gets updated, and it doesn't have to be a symmetrical spatial filter like Robbie or maybe any other image-based filter. So instead of creating those, we are directly creating it with the help of features. So in this case, this is just an example where you'll be having multiple images, and based on the input filter size, like in this case, the input filter size is 5 by 5, so it means it looks for each of the 5 by 5 nearby pixels to identify the unique feature component which may be present in across the images. So that's the job of this in this case. So generally what happens is we do, whenever we carry out any kind of convolutions, so what we do is there are two different approaches which is being followed. One is that you do a zero padding or same value padding, so it means like your image size gets extended, and then you carry out the convolutions. The result of that is the input value will remain same as the output values after carrying out the convolutions. Or in some cases, if you don't give those paddings, then there will be a loss of few number of rows from the images. So this, once these features which gets recorded into a different feature vectors, then what we do is we simply combine them together. So that's why you will see that at the end, if any kind of classification algorithm is there, so at the end the different individual features will get connected to a highly dense neural network, and that highly dense neural network will be used for doing a classification of your data sets. Then in case of CNN based or convolution neural network based, there are other steps which is also being followed. So like if you're having a very large image, and if you just basically reduce its size, the overall feature which was present in any kind of images should remain the same. So it means that even if the information which is present at a particular scale, if you reduce the scale further, the object information is not getting lost. So that's, if that is the case, then in those cases what we carry out the subsampling. So again, there are multiple ways of doing subsampling. Like in this case, we are using an average subsampling. So what we do is we take the average 2 by 2 pixel in the input images and take an average of that, and that average is actually a value which gets generated and placed at the point where that information or where the center of that window is going to occur. Then during the neural network training cases, we may observe that our data set is quickly adapting it to different machine level learning algorithms and providing you the output. But what may happen is that in some cases, if you change the input data slightly, then the prediction may go or the prediction error may increase. So in such cases, to learn or to get the information about information content in terms of kernel weight to be updated in such a way that even if one node is not working, or if even the node of one particular node is having a very high bias, the output will not get affected. So for that, what we carry out is a dropout steps. So what happens is, during the training stage, the connectivity of the network or the weight which we have observed previously will become 0, and due to this computational values of those dropout network getting 0, during the propagation back propagation algorithms, the weight will get updated, and that's how it will lead to a kind of generalization. So in the cases where we expect your data set to be unique and should be capable of generating the output on a multiple data sets, then in those cases it is always better to use the dropout mechanisms to improve your classification. So that's what we can carry on. So with this, actually, we are having with these two basic concepts is an important one, and we may be using tomorrow to see how these all these concepts can be implemented in Python to create a simple neural network for doing an image chip based classification. So what we will be using it at the bottom, we are having a link of your data sets. So what we will try to do tomorrow is that, is it possible to classify all these portion of images into a particular class. So like in this case, we are having a sand, cloud, vegetation and water. So we'll try to identify and find out the cloud, the different unified properties for each of these chips. So this is basically, under this case, each of the chip will be labeled with a particular name. So like you are having a sand, or a cloud, or vegetations and so on. So this is basically a categorization of object identification. Similarly, we may also having a classification scheme. So in that case, what may happen is, instead of providing a label, we have to give the output in terms of each the final layer, and based on that, the classification can also be carried out. But we'll be restricting ourselves to a labeling of different images, and we'll see those back propagations of forward, feed forward neural networks implementations tomorrow. So with this, we are ending today's session. So if you have any questions, please post it, and we'll be answering it very soon.